Good afternoon, everyone, and I believe we are doing well wherever you are. This time I want to welcome you to our afternoon lesson. Today we are discussing physics. Yesterday we've been discussing chemistry all through. So I have two categories of people. I have my online followers in YouTube, which I treasure you so well. So I take this chance to welcome you to our personal foundation learning lessons. So in the meantime, we will be interacting. Allow me to take a minute or two to invite some people to keep following us. So make sure you tell me where you're following from. I'll be glad to know where you are and where you are following me from. Tell me which county, which school, and I'll be very, very glad to be followed by you. Good afternoon, girls and boys. Good afternoon, those who can hear me. How are you doing, Janice? Okay, so welcome to our today's lesson. Just a minute, I'm sending a link to somebody. Then we proceed. Today we are doing physics. From 1 physics will take us like 2 or 3 weeks. Then from there we proceed to Form 2. Then we proceed to Form 3. Yeah, that's the point. So just a minute, I send a link to somebody. Na nimesema wale wa online mtaniambia where you following me from.
Video
Yes, I think now you can proceed. Reikens, je usikie ukiongea leo kama leo umechoka hata usiongee.
Nikiwa ndani
Reikens, can you hear me?
Yes.
Okay. I want us today to discuss measurement 1. Yes. And those who are following me live in my YouTube, tell me where you are following me from, and I'll be very happy. So I want to share screen, then you will tell me whether you can see me. For the next 2 weeks, we shall be discussing Form 1 physics and Form 1 chemistry. From there, we get Form 2 physics and Form 2 chemistry, all through. So you will allow me to move. At some point, I will be moving with speed. At some point, you will have to understand me. Yeah, while when you follow through YouTube, I know you cannot see what I'm presenting. Faria Habdi, we are discussing measurement 1, physics. Can you hear me, Faria? Janice, Sama?
I don't.
You don't do physics? Janice?
Yeah.
Now, see, you remember yesterday we discussed for 2 hours chemistry, yeah?
Yeah.
So we will meet again tomorrow for another 2 hours and on Friday. So.
Okay.
Yeah, so don't worry about that. So can we release you, Janice?
Yeah.
I wish you well.
Okay, thank you.
Thank you. So. Can you see my screen now? Someone who can see my screen? Oh, nice. If you can see my screen, then that's very well. So I would like us to start by looking at the measurement. I want us to discuss or to define the term measurement. What is measurement? Then we see the reasons for establishing of the SI unit. So as you can see from the screen, measurement refers to the process of finding the size of a physical quantity. So if you can measure the distance from one town to another, that is measurement. If you can measure the time it takes you to run from one place to another, that is measurement. If you can measure your weight, that is still measurement. So measurement is the process of finding the size of a physical quantity. And after measuring, we use what we call SI unit to denote the quantity of what you have just measured. And the SI units are used worldwide, meaning they're uniform. So we have the following reasons for establishing SI unit. One is to have international uniformity among scientists, and 2, to avoid confusion among scientists. Those are the 2 main reasons. You can note them down as I'm fixing something here. Eunice Mungai and Reagan, can you see my screen right? Nice. One of us, the 3 of us are doing physics. Studio.
Yes.
Nice. Now, so in that slide, we have 2 concepts. One concept is what is measurement. The second concept is reasons for establishing SI unit. So the first reason for establishing SI unit is to have international uniformity among scientists, and the second reason is to avoid confusion among the scientists. You can put them down as we are moving on. We can check on the next thing here. Types of physical quantities, we have 2 of them. Another one that I'm giving you is types of physical quantities. 1, basic physical quantities, also known as fundamental physical quantities. Yes, basic physical quantities. and fundamental physical quantities. Beverly, welcome. So these physical quantities, basic physical quantities, which are also called fundamental physical quantities, they are 7 in number. And I want to show you in my next slide. They are 7 in number. One thing that you need to know is, first of all, you should know the basic physical quantities, then the SI unit and the symbol of the SI unit. I hope we are together. Can you see my screen again? So we have the first basic physical quantity, which is length. The SI unit is meter, and the symbol of meter is small m. Don't use capital M. Capital M will be used to mean a mole in the chemistry side of it. Mass is kilogram. The symbol for kilogram is small k, small g. We have time, which is SI unit is second, small s. Electric current, we have ampere, capital A. Thermodynamic temperature, the SI unit is Kelvin, which is capital K. We have luminous intensity. The SI unit to luminous intensity is candela, and the symbol is capital C, small d, C, D. Then we have amount of substance, mole. And the symbol for mole is MOL. You just remove E from the SI unit. Are you together, boys and girls? Those who are recording, you can record. Yes. And you can read very fast. Following me online, there's someone who has commented akasema excellent work, sir, following from Shifting Grades Online School. Those who want to learn mathematics, you can check on Shifting Grades Online School. That's my colleague, a friend of mine, anafunzanga maths kwa YouTube yake. Yes. Can I get to the next slide? Well, now, then after basic physical quantities, we have what we call derived physical quantities, and they are obtained through multiplications and divisions from the basic physical quantities. For example, if you want to get area, you always get area through multiplication, depending on the nature of the shape. For example, a rectangle is length times width. It is a derived, you derive it. If you want to obtain density, for example, density is given by mass over volume. So you are deriving density. So we have the basic, which is the 7 I just given you. Then we have now the derived physical quantities, which I'm giving you examples. They include area, volume, work, momentum, density, and anything that you can obtain through divisions or multiplication of the basic physical quantities. Be aware that someone can give you a basic physical quantity, then ask you, name the derived physical quantities obtained from mass, obtained from length, obtained from this and this, and then you're supposed to be in a position of doing the same. Yeah, can we proceed? We need to go. Can we get to the next? I think tulikuwa tumejibu swali siku zingine. Nataka tuareshe ndio tuangalie maswali sasa yake. Okay, we can proceed. Sawa. We have length. Length is one of the basic physical quantities. It is the measure of distance between 2 points. And examples of length include the diameter, the height, the breadth, the depth, and etc. Anything that you can get its length, that is a distance between two places. So how do you define length? Distance between 2 points. Nice. With me on the screen are multiples and submultiples of meter. Remember, meter is the SI unit of length. But apart from meters, we can still measure length in other units. For example, kilometers, hectometers, decameters, decimeters, centimeters, millimeters, micrometers. Yeah. So the task I'm giving you this afternoon, be able to convert 1 unit of length to theater, more so from meters to meters. I hope we were together. Those who are following me online, can you comment yes, we were together? So 1 kilometer is 1,000 meters. 1 hectometer is 100 meters. 1 decameter is 10 millimeters. 1 meter is 10 decimeters. Kuna decameters na kuna decimeters. Decameters is capital D, small m. Decimeters is small d, small m. 1 meter is 100 centimeters. 1 meter is 1,000 millimeters. 1 meter is 1,000,000 micrometers. Record them vizuri because it will help you when you will be doing the conversion of units. There's an exercise over there. You've been told to confirm if this is true. Let's confirm if whatever you are saying on the board is true. Elaine, Mashika, can you confirm if 1,000 kilometers is equal to 1 million meters? Confirm if 0.00025 millimeters is equal to 0.0000025 meters. The way I've given on the screen, in your what to our online. Yes. Beverly, are you confirming number unafanya nini? Okay. Yes, keep confirming. Where are you following us from? The ones in the YouTube. Please don't forget to subscribe and share with as many students as possible. From 2 to 4 in the evening. So feel free. Yeah, you don't need to pay anybody. Just need to have strong Wi-Fi. We can proceed. We can proceed. Measurement of length. measurement of length, there are two methods that can be used to measure length. That is a estimation or a measurement by estimation, and accurate measurement using a suitable measuring instruments. So what are some of the instruments that can be used to measure length? We have 4 of them. One is meter rule and half meter rule. Meter rule is a 1 meter instrument. Half meter rule is always 50 centimeters. Now we have tape measure, and tape measure. We have 3 categories of tape measures. We have surveyors, tailors, and the one used by the fundi. Yeah, so we have 3 of them. Now, then we have finer caliber, and then we have micrometer screw gauge. Yeah. So finer caliber is started fully in Form 2, but we are just measuring it right now in Form 1 that it is used to measure short length, for example, thickness of a textbook or diameter of a measuring cylinder. Micrometer screw gauge is used to measure very short length. Finer caliber is used to measure short length. Micrometer screw gauge is used to measure very short length. Yes. Such as the diameter of a wire. That is the micrometer screw gauge. So those are 4. Tape measure. And then tape measure you kuna carpenter, tailor, na surveyor tape measure. We have meter rule and half meter rules. Then we have finer calibers, micrometer screw gauge. Good. There's a question here. Factors considered when choosing an instrument for measuring length. Factors considered when choosing an instrument for measuring length. We have 2 factors. I'm waiting for you to load so that as I'm mentioning them, you can see whether it is going together with what you were thinking. What are the 2 factors considered? The ones for the online, can you write them for me? Pale chat box. Size of the object to be measured and level of accuracy required. Size of the object to be measured and the level of accuracy. Those are the 2 factors. Yes. Let's look at the meter rule. We all know a meter rule. We all know how it looks like. We all know the length of a meter rule. It's just 1 meter. It is measuring in centimeters and millimeters. There is what you call accuracy. Let me ask this question. What is accuracy of a measuring instrument? It's a question that I'm asking all of us. What is accuracy of a measuring instrument? Yes, sir? Miguel, tuambie.
The smallest reading recorded by an instrument.
The smallest reading that can be recorded by a measuring instrument. True. Now, for a meter rule, the smallest reading is 0.1 centimeters. Meaning, let me write it off. I don't know whether you can see on the board. Miguel, can you see my board using, leave alone the screen I'm sharing. You're using my video here. Can you see it? Can you
Yes.
see it? If I write on the board, can you see it? Nimeandika nini Miguel? Nimeandika nini? Ama imeka.
Physics.
Oh, imeka vizuri, imeandika physics vizuri.
Yeah.
Good. Now, what I'm saying is, a measuring instrument has the least value it can measure or it can record. Like in a meter roll, if this is a meter roll, then we have at this point maybe we talk about 0. So the next here it can measure is 0.1, 0.2, 0.3, 0.4, then 0.5. Next is 0.6, 0.7, 0.8, 0.9, then we have 1. Now, between one calibration to the next is what we are calling the least count, or simply the accuracy of that particular measuring instrument. Now, look here. What if you're told to give the readings here? Are you seeing that arrow? I know it may be very small, like any. Can you see that point? So, what is the answer? What is the readings there? .65. That is from Michelle. Somebody else, I want like 2 answers. Miguel anasema 0.65. Watu wako? Give me some answers there. Niangalie kuna wa 0.65, 0.65, 0.65. Okay, let me see. Now look here, let's agree here. We have 3 correct answers here. We have someone who will give us 0.6. 0.6 is correct. We have the person who will give us 0.7. Correct. These two will be marked correct. Why? Because the arrow is in between. Now, if you give us 0.65, I must see some calculation whereby you give me the average of 0.6 and 0.7. So I must see 0.6 plus 0.7 over 2, where you get 0.65. Why? I will deny you a mark if you give me just directly 0.65. Simply because a meter cannot measure 0.65 unless out of guesswork or approximation. Are you together in a big eye? Yeah, so we say that accuracy of a measuring instrument is the smallest value that can be accurately obtained using the given instrument. As you move on, you will realize that most of the apparatus have their own accuracy. Yes. Now, if you want to use a meter rule, unfortunately I don't have one here, but there are three procedures that we follow. One, you place the meter rule in contact with the object to be measured. Place the end of the meter rule against, place the end of the object against the zero mark of the meter rule. Then you position your eye perpendicularly above the scale. Those are the three procedures. If you don't position your eye perpendicularly, you will get some errors, and the error is called parallax error. Error obtained because your eyes are not well positioned to the instrument to be read, then we call it the parallax error. Now, if you ask this question, give three sources of error when using a meter rule. State three sources of error when using a meter rule. Just use the procedure that we were giving. We will say the following are the errors. So if if the procedure was saying that you place the meter rule in contact, so the error is if the rule is not in contact with the eye or with the object. That is, if the end of the object is not aligned to the zero mark of the meter rule. If the position of the eye is not perpendicular to the scale, those are the errors. And remember, I say this: the error that occurs when the position of the eye is not perpendicular to the scale is called parallax error. Are you recording them? Yes. That was about meter rule. You can proceed. State one precaution when using a meter rule. State one precaution when using a meter rule. Care should be taken to avoid damage to the end of the meter rules. This is because they do not have the allowance. All the meter rules, Mali, Inantia, Babel, zero, mark Inantia. So you should always take, it's not like the rulers you use in school. That is centimeter ruler. Allowance. So if you tear kando, you can still use. But in a meter rule, if you tear the sides, at the end, then it will not continue to serve you properly. Yes. Let's proceed. Tape measures, types of tape measures. Tape measure. We have three. Three. And they will remain to be three. We have Taylor's tape measure, Carpenter's tape measure, and Surveyor's tape measure. And you think this, let me ask, okay, it's a question, but I'm answering it directly. The choice of the tape measure to be used depends on one, nature, two, the length of the distance to be measured. One of the conditions of using a tape measure, ensure it is very taut, T-A-U-T, taut. when induced or very straight, or ensure the temperature is very tight, then it can work out very well. We continue. How do you measure the diameter? How do you measure the diameter of a curved object like this? How do you measure the diameter? Ukipima na hapa juu haitakuwa accurate. Ukipima circular hivi, that will be circumference. How do you measure the diameter of a curved object? Let me explain that concept. I will go to the board. I hope you can see it. The board so that you can follow it up. Faria, are you still following us? Faria? Let me explain how to measure the diameter of a curved object. Are you seeing this photo? It's a curved object. How do we get its diameter? It's very simple. So if this is the curved object, I hope you can see my board. Can you see what I'm drawing? Big guy. We just zoom what
Yes.
I've been. Yes. So if you want to get the diameter of this, it's very simple. Take a thread, whatever length, then let it wrap around this object very many times. Let's say 10 times. After it has gone through it 10 times, take that thread imezunguka hapa 10 times and straighten it. Get its length. It will give you a given length. Let's say it will give you 120 centimeters. So if it was 120 centimeters length that went through this 10 times, then one time, which is the circumference, would be 120 divided by 10. Then you will get 12 centimeters. So this 12 centimeters is the circumference. Then from there, you can do what? You can get the diameter. How do we get the circumference? By the pi times this equals to 12. Then from there you get the diameter of the curved object. Why did I allow it to go 10 times? To increase the accuracy. To increase the accuracy. Increase the accuracy. Now, after getting this 12, I can decide to proceed the second and the third time, so that I will come and add here diameter 1 plus diameter 2 plus diameter 3 over 3. I will get the general diameter. All this, that we are doing it very many times, is simply to. Are we together? We get it? Okay. Sawa. Hapa kuna swali for those who are there. A length of 550 centimeters of a thin thread wraps around a cylinder exactly 25 times. Calculate the circumference and the radius of the cylinder. Calculate the circumference and the radius of the cylinder. Take pi to be 22/7. Yeah. The circumference and the radius. Your thread ya 550 centimeters went round around a cylinder 25 times. So you simply have to divide 550 divided by 25. You can divide 550. Okay, let me explain those guys there. The thread is 550 centimeters, lakini ilikuwa wrapped a certain circular material how many 25 times. So hapa kuna swali, calculate the circumference, calculate the diameter and the radius. So if you take 550 divide by 25, you get 22 if I'm not wrong. So this is the circumference. Then pi d 22/7 times b is equals to 22. You get the diameter. Then you divide the diameter by 2. You get the radius. Are you following? Nice. You can proceed. Kuna swali lingine hapo inasema Philip found that the perimeter of his farming plot was approximately 500 strides. His stride was 1.1 meters long. What was the perimeter of the plot? Ile unatembea, that's one stride. That's one stride. So, but yeye alienda 500 strides around his farm. After going 500 strides around his farm, each stride was 1.1 meter. So what was the perimeter of his farm? Simply 500 times 1.1, you get 550. Yes. Now, I want us to look at the estimation of length. How to estimate length. Estimation of length. Those guys who are following me from YouTube, I will be very, very happy if you just leave a comment. I will be very happy, by the way. Kama tu unanisikia na unanifollow on the YouTube site, I want to see your comment. Then we will proceed. You can imagine that tutaendelea kama utaweka comment. Aya. But what's the meaning of the word approximate and estimate? It means you may not get the actual value, but you get approximately, almost close to. That is the meaning of the word approximate. Now, have you ever seen the longest tree in your neighborhood? Hata sasa ukitoka nje, jaribu tukaa hapo nje utaona. We have a very long tree which you cannot measure its height. Hata ukisema you are good in climbing trees, na upande hiyo miti pale juu kwa the tip of the tree, kuna mahali utafika hiyo tree bend hivi na utaanguka na and you will enjoy a flight. You will enjoy a flight for how many seconds? Like 5 seconds you will enjoy the flight. But after the flight, what will meet you down there, you will not like it. That particular tree. If we ask you can get the height of this tree, we will take you to USA. Some of you are, they are not, you cannot bribe them that he started like a USA. We use what we call estimation method. It's very simple, we do this. Unajua, every object must cast a shadow the ground. Have you ever seen an object casting a shadow away from the ground? Munga, umewahi on an object aina shadow? They have the shadow and they are casting it on the ground. Shadow can be measured. And because it then we will use what we call approximation and estimation method. I will go to the lab, I pick a meter rod or any rod whose length is known. In most cases, meter rod kama hii. Ukishachukua meter rod kama hii, unaweka hapo chini. Then unajiuliza, you ensure that you can find out the length of the shadow casted by this particular meter rod. If you compare 3 meters, this is where now common sense comes in. If 1 meter rule or object measuring 1 meter has a shadow of 3 meters, then here we have a shadow casted by the tree and the length of the shadow is 60 meters. Okay, getting me? And 1 meter rod, or 1 meter rod, iko na shadow ya 3 meters. Lakini pale kando kuna shadow ingine casted by a tree and with the length, but the length of the shadow is 60 meters. Can we get the length and or the height of the tree? The answer is yes. How? Standard ratio. Kama 1 meter imetupea 3 meters, ni nini itatupea 60 meters? 20. So the length of the tree is 20 meters. That's many formulas. One of them is this: height of the rod over length of the shadow of the rod is equals to height of the tree over the length of the shadow of the tree. Are you together? Therefore, tuko pamoja. Haya. Or height of the tree over height of the rod to be equal to length of the shadow of the tree over the length of the shadow of the rod. You will get it very, very well. Na hiyo utapata. Here, there is a question here, which we can look at it together. The length of the shadow of the tree is 1,000 centimeters. The length of the shadow of the rod, 200 meters. Height of the rod, 100 centimeters. Determine the height of the tree. They want you to find the height of a tree whose shadow has a length of 1,000 centimeters. Na lakini shadow ya hii rod ni 200 centimeters, yani times 2. That is 1 meter. Lakini shadow yake ni 200 centimeters. Lakini hapa tuko na shadow ya tree If 100 centimeters length of a road can give us 200, then did you hear me, Reagan, Beverly, Linda, and Michelle? Nice. Can we proceed? Great. Good. Let's get to area. Area refers to the measure of a surface, and area is a derived quantity derived from length. Because the SI unit of length is meters, then the SI unit of area is meters square. Mimi wakati niandike kitu fulani ambao uniambiwa what's the difference? Nataka kuniambia what's the difference between this and this? Difference between meter and meter. M-E-T-E-R and M-E-T-E-R. Like M-E-T-R-E. I think Shawan again. Difference? Kuna S, meter? Sawa. Kimau Mbula, Kijeshi 1. A friend of mine is also teaching physics and chemistry in YouTube, anaitwa Kimau Mbula. Channel yake inajiita Kijeshi 1. So during your free time, by the way, you have a lot of time during this free time. So do this. I've mentioned 2 channels, Shifting Grades and Kijeshi 1. All of them, they teach. I want to comment to level from. So when you are free, you have fun to see TikTok, ingia Ambassador Foundation, ingia, tuko wengi wenye tunafunza, and we will be happy for you and we wish you all the best. Now let's proceed. The SI unit of area is meter square. Apart from area, we can also measure in millimeters square, and we can also measure in kilometers square. Apart from meters square. Are you together? Now, let me tell you, kuna mwanafunzi alikuwa anafanya very simple mistake. Surely, why? Why are you doing this? You are not supposed to be doing this. And alikuwa anafanya mchezo. Anafanya conversion of units in a way that is not pleasing. Kamambia hapana. Look here. Can you check what I'm writing on the board? Kwanza tukunywe maji. Ndio nipate energy. Haya. Somebody anajua vizuri 1 meter is equivalent to an. Okay. Hapo ni sawa kabisa. But where on earth would you make the assumption that 1 meter square is equivalent to 100 centimeters square? Why? No, don't do that. 1 meter square, multiply this by 2. With 10,000 centimeters square. Then 1 meter cubic should be equivalent to. Sasa hii una multiply na 3 is a million centimeters cube. shipping. Tuko pamoja muda.
Yes.
Okay. Sawa. Now look at this. Nataka twende faster. I will not give you a question on conversion. Conversion hiyo ni kitu rahisi. Can you make it a personal responsibility that you can handle all the conversions? But you can handle all the conversions from meters square to centimeters square to whichever units of area or of length. Yeah. So let's look at the basics. There are two ways we can do the area. If the object is regular, we use a formula. If it is not, we use another method of approximation, which I will tell you. So let's tuanze na the normal one you can do on the board, which is rectangular. So I'm going to move very fast. The area of a rectangular is length times width. The area of a circle is pi r squared. Just a minute. Watu wa online lazima niwe. Just a minute. Nice. So if you have an irregular object like your hand, remember your hand is not regular. Your hand is irregular. Or even your ear is one of the most irregular objects we have around. So. What else? Your nose. Can you hear me? Maybe I give you one example. Can you hear me? Maybe I give you one example. So for you to get irregularly shaped surfaces, is the number of complete plus the number of incomplete squares. I can write it on. We write it on the board. Can you see the board here? So if you have an irregular object in a kind, there is no formula you can apply in this particular object. In fact, it will be stopped. So the best just a minute. So you simplify it into areas 1 centimeter square each. Yes, I hope you can see what I'm drawing on the board. Inaonekana Michelle? Miguel? Inaonekana? Kitu nimechora hapo? Okay. Then you come here, you count complete squares. Alafu half times the incomplete. Then you will get the approximation of the area of this particular object. Now, ukiona kuna zingine ziko complete kama hizi na zingine ni incomplete kama hizi, all the incomplete you divide by 2, you simply multiply by half. Then you add the complete ones. It is an approximation. It is not an accurate one. It is called approximation. Umeelewa hiyo kitu? Bema. Yes, can you proceed? Sawa. Now let's get to volume and how to measure volume, how to, there are very many things we need to do about volume. Volume refers to the amount of space occupied by a matter. Amount of space occupied by a matter. Hello. You are lost, Melituba. Yeah, well, the just like area, volume is also a derived quantity of length, measured in meters cubic. Those who are writing, you can write very fast. Those when you amutaandika ni sawa still, but those who are 1 meters cubic is the same as 1 million centimeters cubic. 1 meters cubic is the same as 1 billion, that is 1 with 9 zeros, millimeters cubic. 1 kilometer cubic is the same as 1 billion, 1 with 9 zeros, means 1 billion, yes, meters cubic. Then 1 meters cubic is 1,000 liters. 1 meter is the same as 1,000 ml and 1,000 centimeters cubic. Then 1 liter is the same as 1,000 millimeters. Oh, you the same as, okay, it's well. So I said, can you make it a personal responsibility to know conversion of units? At least choice way, make it a personal responsibility. So kuna maswali hapa, but it's a matter of conversion. Just following on the conversion skill I've just read for you. And you are convert the following to the SI unit. Convert 15 zeros. Ili 1500, yeah. Sasa mtu akiandika zeros mingi hivi, wanataka kufanya aje? But anyway, yeah, kuna shida. 1,500 million centimeters cubic, kama 1.5 billion centimeters cubic, 2 meters cubic, ama to the SI unit. So you simply divide by 1,000, 1 million, yes. And that's okay. Yes. $20 liters convert to SI unit. 1 ml convert to SI unit. 9 billion, 9 zeros 9 millimeters cubic convert to meters cubic. I'm assimilated to the SI unit. Then 1 million liters to the SI unit. Get your answer. Now, want us to get to something else. How do we measure the volume of irregular? No, towards the regular, you're doing the irregular. Regular ni kitu iko kama something regular like this battery. Hii ni battery ya camera. It is regular. It is a cuboid, length times width times height. Alafu baadaye tuangalie zile za irregular. kama isa by 20 na pesa mingi sana. Ni kama ile CS mkomen yenye ilifanya kafutwa kazi. Hii ni irregular. Another irregular object is your head. Irregular. Our heads are irregular and others are highly irregular. Mimi sisi mchokozi nasema. Now, those are the 2 points. Length times width times height. I'm a breadth times height. Length times breadth times height. Then we have triangular prism. Triangular prism with triangle and it may extend. It is our base height. Why? It is actually the cross-sectional area times the length. So it's our base height times the length. Then we have cylinder. Pi r squared h. That is the one for the cylinder. Then we have sphere. Sphere ni kama ball, ni kama mpira. Something spherical. I'm trying to locate the spherical objects here. Anyway, ile mpira yako ya football. It is 4/3 pi r cubic. 4/3 pi r cubic. Yes. Cone. Wacha niwachorie cone. Watu kwanza nione kama inaonekana. Nachora for the sake of those who are following from YouTube. Hii wengine una view my screen very fast. It's a cone. That's a cone. R squared h. One over 3 pi r squared h. Right. Había pasado como que no lo hiyo umeshika. Any other object tumesahau? I think those were the ones zenye tunaweza tukaiangalia. This question zenye nimepost hapo kwa screen. You can copy them for your work. That is now the alternative way you can work. So I'm giving you 1 minute, you copy them. My guys from YouTube. By the way, sometimes we have up to 20, 30 who are following. Sometimes we have up to 5, 0. Can you make it a consistent? That every day 2 p.m. we just meet for a lesson. On Saturday from 2 back to 4 we'll be discussing boards. So that is for the Form 3s now. And Form 2s. Yeah, so make sure you follow me. Thursday, evening, we shall have a session on how are you supposed to spend your holiday as a high school student. How are you supposed to spend your holiday? Jamaa za kuuliza maswali. Good. Now, let me handle something here very simple. I think I handled it in chemistry, but I can still handle it here in physics. Measurement of volumes of liquids. How do we measure the volumes of liquids? We use some specific apparatus to measure the volumes of liquids. Yes. For example, they measure accurately pipette curette, volumetric flask, and a syringe. Yes. Someone on the street showing. No. Yeah. Yes. Can I where? Huh? No.
I was having problems
Okay, you have problems.
on the internet.
Oh. Anyway, I hope your problems are okay. Even me at some point, kuna mahali internet pay anything, but we thank God we can still communicate. We are looking actually at the apparatus for measuring accurate volumes. Na tukasema we have pipette, curette, conical flasks. Tusema conical flask. Reagan. Tusema conical flask. Reagan, tulisema which flask is used to measure volumes of liquids accurately? Volumetric flask. Now, the ones that are used to measure volumes of liquids approximately, measuring cylinder, graduated beaker, conical flask. So uishike vizuri. Measuring cylinder, graduated beaker, and conical flasks. Yes. I hope you all have the diagram of a curette. Yes, of a curette, okay, mostly curette, nataka because curette operates in an abnormal way. When it is full of liquids, it is reading 0. As the liquid drops out, it starts reading. So unashaka kwani inafanya kazi. So when we remove liquids from a curette, the reading increases. I mean, when we remove, the readings increases. When you add liquid to a curette, the readings decrease. increases. I'm not saying when we remove liquids from a burette, the volume of the liquid increases. No, it is the reading on the burette that increases. Yeah, but the volume of the liquid, of course, increases. Those, I know all of us were doing chemistry, and we will be doing titrations. What's happening here is puree is one of the main apparatus for titrations. Yeah. Now, ukipatana na solid kama hii, you can get its volume. Ukipatana na solid kama ile cone, you can easily get its volume. Ukipatana na solid kama mirror, you can easily get its volume. Triangular prism, you can get its volume. But ukipatana na solid kama kichwa yako, which is shapeless, how will you get its volume? We use what we call irregular object. So let's look at that. Measuring volumes of irregular shaped object, we use displacement method. But not every solid we can apply displacement method. Some of them may not work well with displacement methods unless it fulfills the following. Simply the conditions under which displacement method works. If the solid whose volume to be determined is not soluble in the liquid being used, or the solid whose volume is to be determined should not be with the liquid. Number 3, should not sink in the liquid, and so ukitumia measuring cylinder this way, focus on the screen that I'm writing. Nataka kuandika kwa screen. If you have a measuring cylinder, then before you immerse the solid, it is reading V1, then we immerse your solid, irregular solid, ikaenda mpaka hapa, it will read V2. So what's the volume of this particular solid? It's going to be V2 minus V1. That's how we are supposed to work out. That is if we use a measuring cylinder. But what if, okay, apart from measuring cylinder, what else can we use? What else can we use? We can use what we call Eureka gun. We can use Eureka gun. Inakaanga hivi. But iko na spout. Spout ni it removes excess. So you do this. First of all, fill with liquid until ianze ku overflow. Ikianza ku overflow, don't collect those ones. What the yellow. You overflow mpaka the level of liquid sasa iko hapa. Now, put a measuring cylinder here. Remember, measuring cylinder can also measure the volumes of liquids. Then from there, I thought something happening. From there, you immerse your solid. It will displace liquid back for the So the volume of this liquid is the same as the volume of this particular solid. Have you seen that screen, Nani? Miguel? You know again?
Yeah.
Okay, sawa. Yes. Kuna kitu inaitwa meniscus. Do we read the bottom of the meniscus or we read the meniscus? Kwa liquid kwa tena hivi. Ingine itakaa hivi. Ingine ikaa hivi. These are concave meniscus, these are convex meniscus. In all cases, we read the bottom part of the meniscus. Hapa. Just a minute. So, in all the cases, we love to read the bottom part of the meniscus. So, usome ukichukue soma hapa chini. Hata kwa ingine, soma the bottom part of the meniscus. Water always displays this type of meniscus. Mercury displays this type of meniscus. It's all about, by the way. None of us went before tuendelee. Nani ako na swali before tuendelee? I want to look at mass. Nataka tuone mass, how mass is measured. Can you proceed? So we have the mass there. What is mass? It's the quantity of matter in an object. It is measured in kilograms. Apart from mass being measured in kilograms, it can also be measured in other units, such as grams, tons, do we say tons or tons? Then we have milligrams. Yeah. So 1 kilogram is 1,000 grams. 1 ton inakuanga 1,000 kilograms. So if you want to measure the mass of very heavy objects like the masses of vehicles, we work with tons. 1 gram is 1,000 milligrams. 1 kilogram is 1 million milligrams, and 1 ton is 1 million grams. Apa sawa? Tuko pamoja? Michelle? Nice, nice. Kuna maswali ziko hapo. Unaambiwa convert 39.6 milligrams into kilograms. And yake ni 0.0000396 kilogram. Convert 50 tons into grams. Get the answer. Convert 340 tons kilograms into tons. You simply divide by 1,000. Ile ya kwanza, convert 50 tons to grams. You divide by a million. Convert 20 grams into kilogram. Divide by 1,000. Convert 100 grams into kilogram. You divide by 1,000. Good. Yes. So I want us to see how mass is measured. How mass is being measured. Mass can be measured using traditional way or modern way. Okay, so the following instruments are used to measure mass: top pan balance, B balance, and lever balance. I'm categorizing them into two: electrical and mechanical. Top pan balance is very electrical. You place your object on the machine this way, it reads. B balance and the lever balance are mechanical, the traditional way of measuring things. Ulikuwa ukienda kwa kununua nyama, ukitaka nyama kilo 2. Let me tell you how these things used to happen. Na ulikuwa hapo usipochunga, mtu akuja na kunyoa vibaya sana, na wewe jua utajuaje na kujua. Hapo umewekewa balance imekaa hivi. First of all, they must ensure that these distances are the same hapa na hapa. So this person has masses. Kuna mass ya 1 kilogram anawekelea hapa. Wewe ukisema nimetumwa na mama yangu kununua nyama kilo 1, wanakata nyama wakiweka hapa. And hii balance, hii ni kilo 1. Kuna swali nimewapea sasa. But zile zingine electrical, they are very okay because they are very accurate and they are easy to use. Yes. So when you ask about the advantages of electrical balance over mechanical balance, I'm a mechanical type. Say it is accurate and easy to use. Those are 2 points. Yeah. So today ndamalizia na discuss density. Density, that is, it's much engaging, so it's mama katikati. Density is a derived quantity derived from mass and volume. Density is given. I hope now you can see. Let me write on the board. Michelle, you can see my board, right? Ndaka ni utilize it. Now, allow me to discuss density here. We may take some time, but let me discuss it. Density is, how, first of all, we define density? Mass per unit volume. So, if you want to calculate density, first of all, is denoted by a row. There is a letter from Greek known as rho. It looks like P, lakini si P. Naambianga wanafunzi wangu andika ka S hivi. Ukishaandika ka S, tuiweke nini? Rho. Uiweke kitu hivi. That is rho. It is given by density over mass over volume. Whereby mass is given in grams, density in centimeters cubic. So if you have a mass of 20 grams and the volume is 4 centimeters cubic, then you will have 5 grams per centimeters cubic. Are you together? Now, apart from measuring density in grams per centimeters cubic, actually the actual SI unit of density is kilogram per meters cubic. The SI unit of mass is kilogram, and the SI unit of volume is meters cubic. So you can still get it in kilogram per meters cubic. Mass over volume. How do we convert units from grams per centimeters cubic to kilogram per meters cubic? Tumeelewana hivi? Tumeelewana kitu moja, that units ya density ni kilogram per meters cubic or grams per centimeters cubic. But remember, this one is the SI unit. How do we move from this to this or from this to this? 1 gram per centimeters cubic is equivalent to 1,000 kilogram per meters cubic. You need to master this. Are you seeing what I'm writing on the board? Yes, and boys. Yes. This is it. Now, show, there is a question here, show that 1 gram per centimeters cubic is equals to 1,000 kilogram per meters cubic. Show. When you are told to show, you tell us this is it now. Now, let me take a minute or two on the same. swali ni show that 1 gram per centimeters cubic the same as 1000 kilogram per meters cubic. So it's very simple. I'll just say 1 gram over 1 centimeters cubic. Nikisema per ni sawa na kusema over. Let's get that. Then, because the question wants me to get the kilogram per meters cubic, convert 1 gram into kilogram. You'll get 0.001 kilogram over, convert 1 centimeters cubic to meters cubic. First of all, lazima uende kando kidogo uandike 1 centimeters cubic. Answer na tuanze na 1 meter cubic. 1 meter cubic is sawa na 1 million centimeters cubic. Now, convert this in the meters cubic. What about 1 centimeters cubic? So you will have 0.1, 2, 3, 4, 5, 10, 1. So 1, 2, 3, 4, 5, 6. What? Meters cubic. Ukishafika hapo, what next? Mwalimu wako wa hesabu anasemanga hivi. What is the name of your maths teacher, Regan? Regan, umesahau mwalimu wako wa maths. Sawa. Atakwambia multiply with the one with the highest number of decimal places so that yote iondoke. I will multiply here with 1 million. I multiply here with 1 million. Wacha niondoe hii. So we'll have 1000 over 1. Kumbuka hii ni kilogram, kumbuka hii ni meters cubic. So at the end of the day, I will have 1000 kilogram per meters cubic. Umefuatilia vizuri? Nani ameelewa fanya tumefanya? Pale umeshika fanya tumefanya? Well, so that is about the density. Now let's proceed. Kuna kitu mingi nafaa tufanye about the density. The density of a substance is 15 grams per centimeter cube. Express this in SI unit. Express this in SI unit. Simply multiply with 1000. Nataka niwape swali hapa. Can you write this question? Question 4. Sorry. Okay, to find question 4, because I've done question 3. Question 3 is reading, show that 1 gram per centimeter cubic is equals to 1000 kilogram per meter cubic. Hiyo nimefanya vizuri hapa. I think hiyo nimeelaborate vizuri hapo. Swali ya pili inasema, for those who are not viewing my screen, determine the density in kilogram per meter cubic of a solid whose mass is 40 grams and whose dimensions in centimeters are 30, 40, and 3. 30 centimeters, 40 centimeters, and 3 centimeters. So kitu ya kwanza, you can do it in two ways. Convert 40 the easiest is get centimeters cubic, of which I will request one of you to do for me. 30 times 40 times 3. That is 40 times 3. I'm gonna calculate. That one is at 600. Yeah, so 40 divided by that 600. Then whatever you get, multiply by 1,000. You will get it. You will get it directly in kilogram per meter square. So they are being a wooden block of mass 12 grams is 4.0 centimeters wide, 3.0 centimeters thick and 6.0 centimeters long. Calculate the density of the wooden block in kilogram per meter square. Just a minute. Yes. So, ukishapata basi ni 200 grams. Just get the following: 4 times 3 times 6. Then you divide it. Whatever you get will be in grams per centimeters cubic. So, what you need to do is to simply multiply by 1,000. You put in kilogram per meters cubic. We can proceed. We have density bottle, but I think we will start from there on Thursday. Clearly, when is today? Clearly Tuesday. Yeah, clearly Tuesday. Tomorrow, on Wednesday, we shall be doing chemistry. On Thursday, we shall be doing physics. On Thursday, I will have 2 lessons. Okay, in the evening, I will be discussing on how to utilize our holiday. Yeah, you are going to discuss on my channel. There's no problem there. So let's meet on. Okay, we are meeting tomorrow for chemistry, but let's meet on Thursday to answer density portal. Na tumalizane na measurement 1, twende force, tutoke kwa force, twende pressure, tutoke pressure, twende particulate. In the next 2 weeks, tumalizane na form 1, tuanze form 2. Anybody with a question? Kama hakuna mtu akona swali, let's stop there for today. Befani mko sawa? Beverly, I want to see all the other girls from to play in the YouTube tomorrow. So, Beverly, can you put your thumbs up? Melana? We will be discussing chemistry tomorrow. Tell them I want to see them here. So.
Yes.
Right. So, for those who are following me from YouTube, I'm grateful that you are there for me, always. So, for those who want some materials, now it's time to make announcements. Let me make the following announcements. If you want to be added to our WhatsApp group where we share materials, please just text this number 0740 61 90 25. Where we share question papers, we share very many things there. Then at number 2, watching from YouTube is free of charge. But if you feel like you want to support our program, actually we have very many programs. Sometimes finance is the problem. You can support Ambassador Foundation through. Just go to PayPal 755. Sorry, 522 533 7552219. Just put anything that you can put here, so that our programs can keep on running. This is the business number, and my PayPal number, then this is the account number. It will give you Ambassador Solution. So keep on following. We are grateful for that. I thank you. I wish you the best. Tomorrow, please make sure tomorrow you arise again at exactly 2 4. 2 hours. We are okay. Thank you. Have a nice day.